Hey, we have the problem a squared minus b squared equals 285, and we need to solve this for all positive integer values of a and b. To start with, let's do this. We know on the left side this a squared minus b squared can be factored as a difference of two squares, so we can write this as a plus b times a minus b. And then for 285, I want to write that as the prime factorization, which is going to be 3 times 5 times 19. Then again, knowing that a and b are positive integers, we have on the left side here just the product of two integers, right? This is going to be an integer, this is going to be an integer. So what we can do is we can group these prime factors in all combinations of two integers. So let's just see that, like, all possibilities of this to create, this is 285. And we're gonna write it because a plus b, because these are positive integers, a plus b is always gonna be greater than a minus b. Okay, there's no way for the right number to, so we don't have to, so what I'm trying to say is we can have 285 times 1 here, but we can't have it the other way. This can't be 1 times 285. That would be impossible with positive integers. So then let's see, the other combination is going to be, we'll have 19 times 15. We'll have 19 times 3 is 57 times 5. And the last one's going to be 95 times 3. So these are the four possible combinations we can have. So we should have 4 sets of solutions for a and b. And then what we can do is, this makes it pretty nice because then we can just set up a system of 2 equations for each of these 4 sets, solving for, like, a plus b is going to equal 285, a minus b is going to be 1. So let's try the first one to start with. So a plus b equals 285 and a minus b equals 1. We can just add these 2 equations together. 2a equals, b's will cancel, and we'll have 286. So a must be 143. And then you could just plug, well, if we look at a minus b to get 1, b must be 142. Okay, so that's gonna be one solution. Next, we'll repeat the process with this 19 and 15. So we're saying a plus b equals 19, a minus b equals 15. Adding these two together, 2a equals 34, so therefore a equals 17. Then we can maybe just look at this equation. For this to be 15, b must be 2, and that'll be our second answer. Next, we'll look at a plus b equals 57, a minus b equals 5. Again, adding these two together, 2a equals 62, a equals 31. But then looking at a minus b equals 5, so that means b must be 26. That'll be our third solution. Last, we'll look at a plus b equals 95, a minus b equals 3. Same thing, adding together, 2a is going to equal 98. So a is going to be 49. If a is 49, b must be 46, and so that's going to be our fourth solution. Now let's do a quick check of our values. 143 squared minus 142 squared is going to be the same as 204.49 minus 201.64, and that's going to equal 285. Then for our second equation, a is 17 squared, a is 17 squared minus b squared, which is 2 squared. That's just 289 minus 4. That's what actually kind of made me think of this problem, because 289 minus 4 is kind of, that's the one that stuck out to me that made sense, but I didn't necessarily see the other solutions. Then for the third one, 31 squared minus 26 squared is 961 minus 676 equals 285. Then for the last one, 49 squared minus 46 squared is 2401 minus 2116 equals 285. And that's it. Just thought it was an interesting problem. We'll stop it.